Hi friends, I'm back. Hope you're doing good and all is going well. Well, I was working on a project, and this was about Brexit. The impact of Brexit on the UK economy. So I was supposed to perform an econometric analysis of uh, the economic situation, and use GDP as the economic indicator. And I had to regress GDP on its own values. This, I was supposed to perform an autoregressive analysis, and uh, when we talk about GDP, particularly in international trade terms, uh, the trade there is a concept called trade openness of the GDP, which was regressed on its own lagged values, and trade openness was one of the variables uh, on which it was regressed. So it was a composite model. Um, Although, according to my theory, or the theory that supports this work, um, a GDP is a dependent variable, and trade openness is an independent or a predictive variable. However, there in vector autoregression, I mean the way the modeling is done, we need at least two variables which are interdependent, both are dependent on each other. So if we regress both on each other, we'll get results accordingly. But we decided to discard one part of the outputs in favor of GDP being the dependent variable and the trade openness being the independent variable. First of all, when we do a VAR, right? So in a VAR, or it's called a VAR, is a vector autoregression. Vector means there have to be at least two variables which regress on their lag values and the lag value of at least one other variable, right? So in our case, these two variables were, the GDP and the trade openness. We call it TO, right? Now the problem is that when we run a VAR model in EViews, right? EViews. So it does not report the p-values, right? All it reports is the t value, the confidence interval. I'm sorry, not the confidence interval, but the standard error. Standard error and of course, the coefficient, right? Now, so uh, this is a problem for many people because uh, when you have to decide whether a result is significant or not, you have to have p-values, and although standard error does help to an extent, because standard error helps us to find out the confidence, the confidence interval of the coefficients, right? So coefficient standard error gives the confidence interval of the coefficients. However, if we really want to make some decisions regarding, whether the effect is significant or not, we need p-values, right? Now, as I'll show you, um, let me just open this, the data, and here's the data. Let's open it in EViews. Okay. Right. So this is another one. Yeah, this is the sheet. Okay. All right. So we've opened this file, this data. Yeah, here it is. So we have all these variables in this econometric analysis, and our variables of interest are the the UK GDP and the UK trade openness, right? So what I'll do is I'll show how we run a lag1 vector autoregression on these two variables, right? So what I'll do is, let me show you. Okay, here we are. So there's an option called quick. Okay, we click on quick, and then we go to estimate VAR, and then here is, it automatically takes the estimation sample, which is, in our case, it's 1997 Q1 to 2020 Q4, right? And for simplicity's sake, we run a standard VAR in this case, right? And we have the endogenous variables, or the variables, the internal variables, right? Which we can say are the dependent variables, which are within the system. Okay, and there are no exogenous variables, so we take a constant which captures the effect of all the unknown exogenous variables in this model. So first of all, we'll go for UK GDP. Okay, I'm sorry. So UK. Okay, so it gives us a drop down menu, and therein we have, you can see this variable, we just select it and it comes here, and then we have another variable, UK TO, we call it UK TO. It's the trade openness variable of the UK. Okay, so it's UK GDP and UK TO. These are the two endogenous variables in this vector autoregression, and as you can see, it has two. It is by default, it gives us a two lagged interval vector autoregression, but we are interested in only one lag, so we'll make it 1 1, right? Okay, now we just press OK, and here is the output. Now, as we can see here, the results are actually immaterial for this particular video, but let me tell you this part here, right here, this is the coefficient. Okay, this is the coefficient. This is the UK GDP equation variables, and this is the UK TO equation variables, right? And this part, this figure right here, this is the coefficient, and this is the standard error, okay? And this is the t value. This right here, 51.430 is the t value, and this is not the p value, but the standard error. And this is the coefficient 0.98, 9896, right? And this is the constant. Okay, so as we can see, usually it's not a direct relationship, but usually if the standard error is small, then the p-value is also small, and it is likely that the p-value will be less than 0.05, or the results will be significant, right? But that's not an exact relationship. We cannot infer based on this. So we have to calculate p-value, the exact p-value. Unless we do that, we cannot say that it's significant or insignificant. It's just an indication. So in this case, the standard error is 37.79, which is pretty large, right? For a standard error, that's one thing. But another thing is, whenever there is the standard error is small, we can see that the t value is large, relatively large, and when the standard error is large, the t value is small. What it points out is when t value is small, and there is the degrees of freedom is same, right? It's the same for both these variables, for both these iterations, or for both these lags. So since in calculating the p-value, the degrees of freedom and the t-value are the two important inputs. So we can say that if the standard error is large and t-value is small, it is likely that the p-value will be large in general. So we are not talking in exact terms, but in relative terms, right? But for exact interpretation or exact values, we'll have to calculate the exact p-value. So there is no direct way in EViews. It does not in VAR output. It does not report. So we have to run an OLS, right? So don't freak out, because it's a very simple process. It's the beauty of EViews is that it's very fast and simple, right? So we can get it from here itself, right? What we do is we press the proc button. Okay, what we do is we go to proc, and then we go to make system, and then we go to order by variable. Now this gives us two equations, right? So one is the UK GDP equation, another one is the UK TO equation. So at the moment, let's say we are just interested in the UK GDP equation, right? So we select this UK GDP equation and we press the estimate button. Okay, and it opens a dialog box, and this dialog box, it gives different methods of performing running the model, right? And the default method is the ordinary least squares, or the OLS, right? So all we have to do is run this OLS, and it will give us all the coefficients, the standard errors, the t-statistic, and the probabilities. So we can actually check it side by side, right? So here, for the UK GDP dependent variable, it is regressed on the UK GDP -1 or one lagged series of UK GDP, and we have all the information except the probability, right? So the coefficient is 0.98, the coefficient is 0.98, and the standard error is 0.01924. Here is the standard error 0.01924, and the t statistic here is 51.430. This corresponds to this figure right here, and the corresponding probability is 0.000, right? So like I said, that whenever there is a, a small standard error, right, it is likely that the probability will also be small. Let's see if it's true, whatever I said. Let's see if it holds here. So we have standard error. This is a small standard error, right? And the t statistic is large, much larger than 1, right? And the probability is less than 0.05 or 0.01 or even 0.001. So it is highly significant, right? And then for this value right here, for the UKTO, I don't think, I mean, we can just, by looking at this result, we can just say that it should be not significant, right? Because the t value is very small and the standard error is very large. Let's see what is there, the reality. So the probability in this case is 0.80, and this is definitely not significant because it's greater than 0.05, right? Similarly, let's say we can take these values right here. Okay, so we don't have the UKTO values, but let's see whether the constant is significant or not. So, okay, for the constant, again, it's a large standard error, which means the p-value should be large. But how large? Let's see here. So for the constant, this is the value. This is the coefficient for the constant, and let's see. Yes, so the p-value is 0.1344, which is greater than 0.05, and so this is not significant. So in essence, we learned two things right here. First of all, this moment. Yeah. So we did two things. The first thing we learned is how to calculate, or rather work out. I'll say work out because it's EViews that does it for us, right? So we work out the p-values for a given VAR model, right? And the second thing, a very important insight or very important observation is that larger the standard error, greater the p-value, which means it is likely rather the coefficient is likely to be non-significant. Okay, the coefficient is likely to be non-significant if the the standard error is large, or there's another catch to it. Larger the smaller the t value, smaller the t value, again greater the p value. So again, even in this case, the coefficient is likely to be non-significant. The coefficient is likely to be significant if the t value is small, right? So this is a very general observation, but to determine exactly, we need to calculate or work out the p-values. Now how we did it? What we do, first of all, let me tell you step by step. We open the data file in EViews, then we select the variables. Third, what we do is we just go ahead and run the VAR. So it's simple up to this point, right? After this, what we do is we go to proc. Okay, you see this, it's there in the same window, the VAR output window. So we go to proc, and then we go to make system. And we're selecting the equation, right? It gives us an option for selecting the equation, and it says select by variable. Select by variable, right? And another is select by lag. So we select by variable, right? What we do is we select by variable, and then we go ahead and we run the OLS. Okay, we press OK, and this gives us the p-value. Simple. So it looks like a long process, but the most important part is you just go to the proc, and then we go to make system. We select the select by variable, then we go to OLS, and then the p-value, right? That's it. That's all. So that's it for today. I hope you liked this video. Just you can just put your comments in the comment box, and do not forget to subscribe to the channel and like the video. Thank you. Till then, bye bye.